Chapter 7, Section 3 is about solving systems, but this time we're going to use something called elimination. So by the end of this lesson, you should be able to solve systems of equations with this new method, and then analyze the special types that we keep talking about. So remember, from the past 2 days, there are 3 possible solutions. So one solution is when you have an ordered pair that makes both equations true. So remember, when you graph it, it's where the 2 lines cross, and you get a point for your answer. You get something for x and something for y. For infinitely many solutions, remember, that's when you have the exact same line. So I'd graph it, and then you end up graphing right on top of it. And because this is infinitely many solutions, remember, you get a true statement. So you would end solving it with something like 3 equals 3. This is always true no matter what. And then the last one we talk about is no solutions. This is when the lines are parallel, and this is when you get something that doesn't work, or a false statement. So you would end a problem and you'd get something like 3 equals 8. This can never happen, so that means that there's no solution, there's no point that works. So in the 3 methods to solve, we've done graphing, we've done substitution, and today is elimination. So here's some steps. The first thing you want to do is make sure your equations are lined up. Usually we use standard form. So you want 2 equations that look like ax plus by equals c right on top of each other. And then what you're going to do is either add or subtract the equations to eliminate the variable with a common coefficient. Remember, coefficients are the numbers in front of the variables. So this number here is your coefficient. And then you're going to solve for the remaining variable. And then even though this is elimination, we're going to use substitution. So when you get done solving, substitute your answer into either original equation and solve for the other variable. So there's a couple more steps than there was to graphing or substitution, but elimination is my favorite. This is the one I tend to use the most. So solve the system by elimination, check your solution. So first thing, make sure your equations are lined up. That means x is on top of x's, y is on top of y's, equal signs in the same spot, and then plain old numbers in the same spot. So that's done. Next thing, add or subtract to eliminate the variable with a common coefficient. So if you look at these here, both of these y's have a 6 in front of them. One's positive and one's negative, so that means when we add these 2 equations right here, something awesome is going to happen. 5x plus 3x gives me 8x, but negative 6y plus 6y gives me no more y's. They totally disappear. And then negative 32 plus 48 gives me 16. So this turns it into a pretty easy equation to solve. We can easily see that x equals 2. So just like substitution, we need 2 answers here. We need an answer to x and an answer to y. So we've done this stuff, solve the equation for the remaining variable, and now we're on this part. Substitute your answer and solve for the other one. So it doesn't matter which one you plug it back into. Choose your favorite. Let's plug it into the first one. So everywhere that I see x, I'm going to replace it with what I know x equals. So I get 10 minus 6y equals negative 32. And then you just solve like normal. If I subtract 10 from both sides, I get negative 42. Then if I divide both sides by y, I get positive 7. So just like any other time we've done this, instead of writing them as 2 separate answers, combine them into an ordered pair, 2, 7. And then again, just like all the other ones, you can plug this in and double check that it works. So in order for it to work, both of these would have to work in both equations. So plug in 2 for x, 6 times 7. So 5 times 2 is 10, 6 times 7 is 42, and if you subtract those, you definitely get 32. And then do the same thing with the other equation. 3 times x plus 6 times y should give me 48. x is 6 plus another 42 definitely gives me 48. So I know without a doubt that that is my answer. So let's try another one. I know it's very tempting to see this and think, okay, let's just start adding things up. But step number 1, remember, is make sure everything is lined up. Your x's are lined up, your y's are lined up, your numbers are lined up, your equal signs are not. This means that we cannot just go adding straight down. What we need to do is make sure that everything is on the same page. So what I'm going to do is just take these 3 y's and move them to the other side. So this equation turns into 6x minus 3y equals 3. And then I'm not going to do anything with this equation. Negative 6x plus 5y equals 3. So now that they are lined up, I want to get rid of my x's. So because one's positive, one's negative, all I got to do is add these up. My x's go away. I get 2y equals 6. And again, really easy to figure out what y equals. It's a little more work to figure out what x equals. So once we know that y equals 3, take it and plug it into either equation. Let's plug it into this one. Negative 6 plus 5 times 3 equals 3. So negative 6x plus 15 equals 3. Subtract 15 and divide by negative 6. So just like before, we could plug this back in and check it. If it was on a test or quiz, I definitely suggest you do that. So they're not always going to be this easy, or things just automatically cross off. Like this next one here. If we take a look at what we have going on, first of all, things aren't lined up. Our x's and our y's aren't. So let's rearrange these equations. I'm going to put the x's first. 2x plus 3y equals 4. And I didn't move anything from one side to the other. All I did was switch these around, so no need to subtract. But if I look at what I have here, if I was just to add these, nothing would cross off. We need something to eliminate. That's the whole reason this is called elimination. So before I can eliminate anything, I have to make either x or y go away. And this is where you have choices, which can be good or bad. You get to decide what you want to eliminate. So when I'm looking at this, I know I can turn this 2 into a 6. All I would need to do is multiply this whole equation by 3. Or I could turn this 1 down here into a negative 3, and I would have to multiply all of those things by negative 3. Now it doesn't really matter which one you choose, but I'm going to do the first one. I'm going to turn this 2 into a positive 6. So in order to do that, I need to multiply everything in this equation by the exact same number. And that number I'm going to pick is 3. So then you distribute. 3 times 2x is 6x. 3 times 3y is 9y. And 4 times 3 is 12. Now I made this equation exactly the same. I just made it 3 times bigger. So now that when I add the red equation and this light blue equation up, my x's go away. I get 10y and it equals 5. Now this is easy to solve. And once I know one, I can plug it back in to find the other one. So if we go and plug this back in, 3 times the y I just found is 2x equals 4. This is 1.5 or 3 halves. If I subtract that from both sides, and then divide both sides by 2, I get 1.25. So my point where they would cross is 1.25, comma, 0.5. And again, just like before, you can plug it back in and check it. So this next one, it's kind of a mess. If we look at this, nothing is lined up. So let's put both of these in standard form. This bottom one is good. This one here needs some work. This 32 needs to move to the other side. So what I'm going to do is subtract it. So this turns into negative 2x plus 15y equals a negative 32. And then my other equation, let's just rewrite so they line up. Now just like the last one, nothing here crossed off. So I need to make some choices. What do I want to get rid of? Do I want to get rid of x or do I want to get rid of y? If you want to get rid of x, we would have to turn one of these into positive 14 and the other one into negative 14, because 2 and 7 go into that. Or if I look at these ones, 5 goes into 15. So it's going to be a little easier to get rid of my y's, because all I would have to do is multiply this bottom equation by 3. It's already negative, where this one's positive. So if I multiply it by 3, I end up with 21x minus 15y equals 51. And then let's just rewrite this other equation down here so we can add them up. And then it's really easy to see that our y's disappear. We get 19x equals 19. So x has to be 1. And then once we know x, plug it back in to find y. And remember, it doesn't matter what one you plug it back into. Let's plug it into the bottom one, because that one looks a little nicer to me. So I'll plug it in. 7 times 1 minus 5y equals 17. If I subtract 7 from both sides, I get negative 5y equals 10. So y equals a negative 2. So my answer is 1, negative 2. So just like before, all of these have had one solution. We've done 4 different problems where you get a point out. With elimination, finding something that has no solutions or infinitely many solutions is very similar to substitution. So let's do this next problem here. If I want to solve this by elimination, figure out what you want to get rid of, x's or y's, and it doesn't really matter, just like before. If we would decide to get rid of x's, this one's 4 and this one's negative 2. So that means I need to multiply this guy by 2 to turn it into a 4. So I get negative 4x plus 2y equals 6. And then if we just rewrite the other one, hopefully you're starting to see something happen. When I add these up, when I go to eliminate my x's, something else happens. I also eliminate my y's. So this whole side becomes 0, and then this side is 14. Now, just like before, this is not a true statement. 0 can never equal 14. So this means that there are no solutions to this problem. And if you were to graph them, they would be parallel lines. Same kind of thing for this one over here. First thing you want to check, are they lined up? And in this case, they're not. So let's add x to both sides. So we get x plus 2y equals 10. And x plus 2y equals 10. And if we get these to disappear, remember we can also subtract. So if I do x minus x, I get 0. 2y minus 2y, I get 0. And 10 minus 10, I get 0. Unlike this last one, this is a true statement. 0 equals 0 all the time, all day long. So because of this, we know there's infinitely many solutions. And if we were to graph this, as you can see by these two here, it's the same exact line. So for me, it's really easy to see when things are infinitely many solutions in elimination, because you get the same line, and when it's no solutions, because everything crosses off besides your C values over there. So you should be able to solve this system by, this should say elimination. This is the exact same equation that I have given you the past 2 nights. Rearranged it a little bit, got rid of that fraction, but you can either plug this back in when you get done or make sure you've gotten the same answer for the past 2 can you prove it's. Make sure you write down any questions you have and we can go over them in class. Have a good night.